Hello everyone, I guess we are live now. Can you confirm my audio and video is clear? There is no issue. Okay, so we are live. How was the contest? You, how was the contest? It was like quite easy. Or it was quite good contest. First three were really easy. Like you don't have to put any brain in that. How many solves did you guys have? One, two, four within 15 minutes. Why not third? Hi, why not third? Doing CS stream. The both the contests collide, so I have to choose one of them. So I discussed with Shayan and he said like bi-weekly. So we will provide like uh, post contest discussion in the recorded form. I will solve it later if possible. But it looks like ad hoc. I'm not so good at it. It's not ad hoc. Like, this quite uh, intuitive type of flow. Not intuitive, not ad hoc. What was that? We will discuss. Okay. So let's start with our post contest discussion bi-weekly contest 178, and we will like go through the problems really quickly, okay? Because fourth one it was really nice problem. I like that. I in today's morning I was discussing with one of my friend, and I was saying to him like digit DP is quite rare nowadays. You don't see problems on digit DPs a lot. Then suddenly in today's context only you get a digit DP problem. Fascinating. Okay, so in this problem you are given with an integer array norms. Return an integer denoting the first even number earliest by the array's index that appear exactly once in the norms. Okay, if no such integer exists, return -1, and you are given an integer x and is considered even if it is divisible by 2. Okay. Oh yeah, sorry. My one note is not there. Okay. So in this problem, you are given with an array which consists of multiple integers. One to a straight away implementation of yeah. And same nothing any platform to host a CP contest in the college. You can do on any of the platforms which have been collaborated with the college. So let's say your array contains 1, 3, 4, 2, 4, 6. Okay, so this is your array. Now I want to find first even integer which has frequency 1. Okay? Which has frequency 1. So which is that integer? Look, the first even is 4. No, but it has frequency of 2. The next even is 2 and it has frequency of 1. So I will print 2 here. Okay, so 2 is my answer. Now you can straightforward do this by putting uh, every element in the map. So after putting every element in the map, it will be like 1 has frequency 1, 3 has frequency 1, 4 has frequency 2, 2 has frequency 1, 6 has frequency 1. Okay. Now, after putting them in the map, what you can do, you can just iterate. Okay. Just iterate from 0 to n. Check if number is even and your frequency is 1. So if both of these condition is correct, which means on AND condition, so both of them is correct, just return that integer. Okay? Return that nums of I. That's it. If your for loop ends and you still not get any answer, then you can return -1. Okay, easy peasy. There will be a CM50 discussion today. Not possible because of contest aligned. together. So easy peasy. As we look at the code, you can see I have made a map. Then I have put every integer in the map with their corresponding frequencies. Then I have iterated over nums again. Check if the frequency is 1 and it is an even integer. If both of them is correct, then I can just return that integer. Else, I have not got any integer, then it will return my answer. Okay, so that's it for this problem. I guess it is quite easy and like straightforward. You just have to implement everything. All right. So next problem. Here, in this problem, you are given an integer array nums of length n. Construct an array prefix GCD where for each index I, let mxi be the max of all the element up to I. So you have a prefix max going on. Okay. Then you make the prefix GCD array as GCD of current integer and the maximum integer till now, the prefix maximum integer. All right. After constructing this array prefix GCD, you need to sort that in non-decreasing order, which means sort normally. Now form pairs by taking the smallest unpaired element and the largest unpaired element. Repeat this process until no more pairs can be formed. For each formed pair, compute the GCD of the two elements. If n is odd, middle element will be skipped because it cannot be paired. Okay. So you need to return the sum of the GCD values of those pair. Okay. Really straightforward problem. He has told you every single thing which you have to do. Okay. You don't have to even think for yourself. No. All right. So you are given with an array. Let's take some random array. So 5, 1, 4, 2, 3, 6, 7. Okay. This is my random array. Now I have to compute prefix GCD array. Okay. And for this particular prefix GCD array, each index has the GCD of maximum element till now and num_i. Okay. So what is the maximum element till now? 5. And what is num_i? 5. So GCD of 5 comma 5 is 5. Okay. Now I have gone till here. Now what is the maximum element till here? It is still 5. But GCD of 1 comma 5 is 1. So I will put 1 here. Now increase. What is the maximum element till here? Still 5. What is GCD of 4 comma 5? It's 1. Increase it. So what is the maximum element till here? 5. GCD of 5 comma 2? 1. You go ahead. You go 5 and 3. Still maximum is 5. GCD will be 1. You go 5 and 6. Now the maximum is 6 and your element is also 6. So GCD of 6 comma 6 will give you 6. Okay. So you put 6. Now you go 7. Maximum element is 7 and GCD of maximum element is the current element which is 7 comma 7. It will be 7 again. All right. So this is my prefix GCD array. Now he told me to sort this. Okay. Second step, sort it. So after sorting, the array will look like 1, 1, 1, 1, 5, 6, 7. After sorting, now he has asked to choose smallest unpaired and largest unpaired. Okay, so what is the smallest unpaired? It is 1. What is the largest unpaired? It is 7. Now take both these numbers and take out the GCD of 1 on 7. It comes out to be 1. Okay, so add 1 into your answer. Plus. Now you don't need to consider both of the elements. I just erase it from here just for convenience. Now you take another smallest and largest pair. So smallest is this, largest is this. You again do GCD of 1 comma 6. It comes out to be 1. Now you add 1 again into your answer. Now erase them for your convenience. Now take 1, take 5 again. Now GCD of 1 comma 5 comes out to be 1. Add 1 again to your answer and erase them. Okay. Now there is a single element left in the array, and he has already stated if single middle element left, then you just don't need to do any operation, skip it. Okay. So now my answer comes out to be 3. Okay. So I need to just write the code for this particular algorithm. Okay. So as you can see, what I have done, I have made a max value which is currently assigned as -1, and I will make a prefix maximum in this. Okay. I made a prefix GCD array which is named as pref. Now you iterate over 0 to the size of the nums and take the maximum element. First you take the maximum element till now. Okay. So you got the maximum element. Then what do? You make your prefix I as GCD of maximum element and the current element. Okay. So your prefix GCD will be ready. The array prefix GCD. The second step, it was to sort. I have sorted the array. Now, hello. Uh, Now what you have to do? You have to take uh, the maximum and smallest and the largest pair. So smallest will be always on the left hand side and largest will always be on the right hand side. So I made two pointers, which is I is equals to 0 and j is equals to n minus 1. Now I have made a long answer because the expected answer is in long. So you make a long answer. Then you iterate two pointers until I is less than j because you are not taking the center element. Add the GCD of both of the prefixes, increase your pointers and decrease your pointers, and then you can just return your answer. Everything is just given in the problem. Okay. So you just have to write the algorithm. Yeah, I have solved it. Okay. So we will discuss B. Okay. So that's it for this problem. Now we can just move towards third one. Is this clear? Like, I don't suspect any one of you not able to solve this. Okay. Now this problem. It is also a 4-pointer problem, quite interesting. You are given an array, two integer arrays, nums1 and nums2 of size n. You can perform the following two operations any number of times. Okay. So first operation is swap within the same array. So you choose any two indices and you can choose to swap either nums I and nums j of the first array or from the second array. Okay. And this operation is free of charge. So I can swap any number of times in my array and it won't charge me anything. Okay. The second operation is swap between the two arrays. So I choose an index I, then swap nums I and nums2I. Okay, so I swap between both of the arrays. So this is like vertical swapping, and the first operation is like horizontal swapping. For horizontal swapping, you are not charging, and for this particular operation, you have to give a cost of 1. Okay. Now you need to return an integer denoting minimum cost to make nums and nums2 identical. Okay, so if it is not possible, then you can return minus. All right. Look, you can also look like who was not able to like come up with that. All right. So in this problem, let's say my nums one is like, let's take some example. I will take 1, 2, 3, 4, and one is frequency. Let's place that. Two is frequency. All right. So this is my array. Now, as I need to make this identical. So for making this identical, I have two kind of operation. First is horizontal swapping, like I can swap like this. It will give me a cost of 0. And the second operation is I can swap like this, and it will give me a cost of 1. Okay. So I need to minimize this operation. So first of all, let's arrange both of the array uh, in some way so that each similar element can come in between or each of them. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Oh, sorry, it has a length of 5. Now, this is, let's say, A array and this is B array. So I have rewritten my arrays as 5 and B will be 1, 3, 4, 4, 4, 4. Okay. Now I rewritten like this because it won't cost me anything. First of all, there is no cost. And second thing, I can check where I need to perform the second operation. Okay, so I can check where I need to perform the second operation. Alright, look how. As you can iterate from index 0 to n, and I can see this indexes matches each other, so I just skip it. These don't match. Okay, so to match this, what I have to do? I have to put one operation which is skipping any other two which can come up to here. Okay, so let's skip it. So it will be 4 and 2. Correct. Now I can swap again. So swapping won't cost me. So I can just write it like this. 3. Okay. Now you look. You again see this thing like now you come up to something where you don't have any 3 left in the array. So there is only one 3. You cannot make uh, both of the array identical because there are not enough element to put in those positions. Okay, so you cannot put 3 here at any cost. Okay, so you cannot put 3 here, it is not possible. So here I can just return like -1 because I cannot do this. So what is the one operation I observation I got? So my observation is, first, if there are odd frequencies, you can never make them identical. Okay, it is true or not? Because if you have 7 frequency of an element as 7, then how many ways you can do? Like there will always be one 4 uh, there will be 4 element in one array and 3 element in the second array. Whatever you can do, therefore they cannot be identical. Okay, never make them identical. Second observation is, order don't matter. Okay, whatever order you have of any array A or B, that order doesn't matter to me. Okay, so doesn't matter. English left that chat. Okay, so order doesn't matter, right? Third thing, what I have deduced it, the number of operation, the number of operation is how much. I need to calculate this. Okay, for each times. Okay, let's see some example where answer is not -1. So they're really bad examples. Okay, so let's make our own. So first example is 1, 1, 1, 1, 1, 1. Okay, and the second one is 2, 2, 3, 3, and 4. Okay, so these are my array. Okay, now order don't matter, and I need to count the frequency. Let's make a map and check how much frequency difference we have in both of array. Okay, like for in this array A, I have 6 1, and in array B I have only 0 ones. Okay, so I don't have any one. So the number of operation will be swapping these 3 ones into this. All right, so let's make a map first. In my map data structure, I have 1 as 6 currently, Okay, so this is for the first array A. I got map as 1 with the frequency of 6. Now I come to array B. Now when you come to the array B, you just reduce the number of element which you have. Okay, so 1 you have with 6 frequency. You have 2 with how much frequency? I have just told you you need to reduce that. Okay, you will put 2 as -2. I will explain why. Then you have 3 with -2 and 4 with -2. Okay, so you have these frequencies. Why -2? Look, now because when you operate on any of the one and swap it with the corresponding element, this element which was not available in this array will automatically get to that array. Okay, so when you swap this particular thing, 3 will automatically get to the first array and 1 will come down. So you perform one operation and two things occur at a time. Okay, which means for a single operation you can perform a value of two operations. Okay, so the total number of operation to take all the ones into all the three ones into B, it will be the difference frequency divided by 2. Okay. So this is your number of operations to take anything down. So if you take this anything down, you can just make sure that your frequency which are negative, which means they are in the B, they will automatically get into A. Okay, great. Alright. So yeah. So what I am going to do, I will make a map, put frequency of nums 1, nums 1 as positives and put frequency of nums 2 as negatives. Okay, so it will give me a difference. So this will give me difference. So this will give me difference between both of them. Great. Now I got differences. So if any of the difference is like even, or so any of the difference is odd, so if any of the difference comes out to be odd, then you can never make array equal, so print -1. Else it will be even, and if it is even and it is like positive difference, which means I have to take elements from A and put it into B. Okay, positive difference means you have to take element from A and put it into B, and when you perform this operation, a negative element from B will automatically get into A, and this will correspond to operations which can be worked into one. Okay, which can be you can combine them into one. Okay, so if difference is greater than 0, I can just add answer plus is equals to difference by 2. So because I am doing two operations, so, and the cost of the both of the operation is counted as one for this particular case, as you are taking some element down to B, one element automatically will go to A, and this will this originally is two operation, and but I am doing one according to the problem. Okay, so I just divide difference by 2. Okay, correct. So let's look at the code. Now as you can see, I have made a map. I have put all the elements of nums1 as positives, so I have increased their frequencies, and I have put all the elements of num2 as negative elements, so I have decreased all the frequencies. Now I have made a total cost which is currently 0. Now you iterate over your map. If your frequency is comes out to be odd, so you just return -1. else your frequency will be even, and if it is greater than 0, which is a positive frequency, you have to take element from A and put it into B. You just increment your cost by that frequency divided by 2. So this is just difference of both of the frequency, because I have made a single map. You can do in two maps also, but it is quite complicated to write. This is the easiest way you can write. Okay, then you can just return the cost. Is this clear, or is there any doubt in this problem? Like, there are a lot of complications in this. You need to take care of two things in this problem. Is this clear or not? If it is clear, then we can just move towards next problem. Is this clear, or there is anything you are not able to get? I can re-explain. Near about 300 something, maybe. I'm not sure. Okay, so let's move to a D. Okay, don't look at the code. Okay, first of all, you should not look at the code, as you will get demotivated. Alright, so in this problem, you are given two integers L and R, and there will be discussion of safe round. No, there won't be any safe round to discussion live because of clash of two requirements. Yeah. So you are given two integers L and R. An integer is called good if if its digit form strictly monotone sequence, meaning the digits are strictly increasing or strictly decreasing. All single digits integer are considered as good. An integer is called fancy if it is good or the sum of its digit is good. Okay, so we are given as a good integer. It is like it has strictly monotone sequence, which means it is in strictly increasing or strictly decreasing form. An integer is called fancy if it is good or its sum is good. Okay, return an integer representing the number of fancy integers in the range L to R inclusively. A sequence is said to be polite. This is quite a good problem. Okay, even if you don't know digit DP, you can solve this. Okay, I am given with the range L to R. I need to count fancy integers. Okay, first of all, what is a good integer? Okay, a good integer is the digits are either strictly increasing or decreasing. Okay, increasing or decreasing. For example, 14510 320. These all are good integers. Okay, and as they are good integers, because their digits are increasing, look, 1 is less than 4 is less than 5, 1 is greater than 0, 3 is greater than 2 is greater than 0, so these are good integers. Now comes to fancy integers. Okay? Fancy integer is an integer which is either good or sum of the digits is good. For example, 144. Okay, so this is my example. Now this is not a good integer. Why? Because one is smaller than 4, but 4 and 4 are equal. These both of them are equal, so it is not a good integer. But sum of its digit is 1 plus 4 plus 4, which comes out to be 9, and 9 is a good integer. So sum is good, so it is a fancy integer. So 4 is fancy, 144 is fancy. Alright, because 9 is good, sum of its digit is good, so it will become fancy. Correct. Every good integer is fancy integer. Okay? Great. Now, how can I do this? First of all, I cannot iterate iterate up to r, okay, up to L to r, because r can be funny 18, and iterating will or cost near about some couple of hundred of years, and till then, like, AI will take our job, so we cannot iterate over r. So what I can do, I can generate how many good integers are there on it. So how many fancy integers, so not good, fancy integers are there. Now look how I am going to do this. First of all, if you are able to count the number of fancy integer from 0 to r, then you can also count from 0 to l, right? Then you can just do function r minus function l minus 1 to get a range. This will give you a range or not. This will give me number of fancy integers between L to R. Okay, so this thing will give me number of fancy integer between L to R, where function R will run from 0 to R and function L will run from 0 to L minus 1. So you will get the number of fancy integer in between the range. Okay, please stop me at any point if you get like this is getting out of my mind, I'm not able to understand. Okay, now I'm going to generate the number of integers. Let's take some example. 10 and 20. So this is my L and this is my R. I need to count the number of fancy integer in between 10 to 20. So 10 is a fancy integer. Okay. 11 is also a fancy integer because the sum is 2 and it is fancy. 12, 13, 14, 15, 16, 17, 18, 19 and 20. All of them are fancy. So all of them are fancy. Okay. So I need to count because I cannot iterate. Okay. So what I'm going to do, I will try to generate all of the pairs. Okay? So let's take for 20 only. So I am sending 20 as my R. Okay. First of all, you need to convert this into string. Okay. Convert this into string, so it will become a string of length 2. So there are two indices. Great. So I will first try to make the first index. Okay. So it is currently 2. So I have three options. Either I can put 0 here, either I can put 1 here, either I can put 2 here. Yes or no? Please write in the comments, like I'm not able to know if you are not able to understand or if you are lacking in something. Please write in the comments, like I can get to know about this. Okay. So I'm not going to digit DB part. I will just try to do this by intuition. Okay. So what I'm going to do, I am trying to make this first particular place, and for that I can place either 0, either I can place 1, either I can place 2. Look, if I'm placing 0, how many options I have? I can place all the integer from 1 to 9 in the next part. Yes or no? So it will become like 0, 1, 0, 2, 0, 3, 0, 4 up to 0, 9. Yes, 0, 0 also. 0, 0 up to 0, 9. I can make them yes or no. For 1 also I can make from like 1, 0 up to 1, 9. But for 2, you cannot make 2, 0 up to 2, 9. Why? Because the next integer where you are placing this particular uh, uh, digit, where you are placing this particular digit is 0, which means you have a boundary condition or you have a bound that you cannot go beyond 0. All right, because it will like increase my number. If I take 21, it will go out of the bound of r. Okay, so I need to take care of this. Like if it is was 25, let's say it was 25. Okay, 25. So you can make numbers up to 20 up to 25, but not beyond this. Clear? Here I was able to make numbers beyond 5 because this particular integer, this particular integer is less than the previous one. Yes or no? Please tell me that everything is clear till now. Then I will move forward because this is the very base of digit DP and how to construct a number. I have just made a diagram so that you can understand. So just tell me if this is clear or not. I will wait. I will just drop my pen and I will wait. Okay. Please, please let me know that till now everything is clear or nothing is clear. Please guys let me know in the comments. I will wait. Okay. Everyone just open the live stream and just we are going to implement this. Yeah, I will show you how to implement it. Okay, step by step. We will go step by step. When you have an implementation heavy thing, just try to do whatever you have written in your notebook. Okay, so I have started with like making the index. So I will write IDX first. Then I will go into the second part. Then I will go into the loop part because as you can see, I am trying to make all the numbers from 0 to yes, okay. Go one by one, one by one. You can just write the particular code. Okay. So what all things I have noted now? Okay. I know that I have to iterate recursively over the string. Okay. Then try to generate all the possible answers. Okay. All the possible answer or all the possible numbers. Okay. Correct. So I know till now I will generate all the possible numbers. Now the second thing I will do is I will try to check the goodness. Okay. Or goodness, which means the number is good or not. Okay. I will try to check the goodness of the number. Okay? So let's look at this part. Okay. So I have to check two things. It is either it is an increasing, either it is in decreasing, okay, or it is like broken number. Broken means it is neither increasing nor decreasing, which is something like this. Okay, one fold. So it is neither increasing nor decreasing. So this is a broken number. I am trying to check goodness, but I am not trying to check I'm not trying to check fancy number. Okay, I'm just trying to check good test. Okay, let's go. So first thing is check increasing, check decreasing, or check broken. So I can make a flag to know what I'm having, right? So I can make a flag of increasing. Let's say it is named as 1. For decreasing, it is named as 2. For broken, it is named as 3. Or your convenience, you can make it as I, D, B. This is also good. Okay, you can make a character I, B, D. Okay. Now, if till now, look, now I am going into mid recursion. Like I am not standing on a top, or I am not standing at the bottom. I am somewhere inside between the. Okay, like you are trying to generate a number like 1, 3, 5, 6. Now you got digits where you can place digits from 0 to 9. Say you can at this place you can like this. Let me write it more properly. So this is your number, and you have placed 1 here, you have placed 3 here, you have placed 5 here and 6 here. Now you are trying to place number here, and there are more numbers ahead of you. Okay, but you are trying to place number here, so you can place up to 0 to 9. Okay, you can place up to 0 to 9. Okay, great. So if I can place up to 0 to 9, then if I placed 0 here, okay, this will get broken. Okay, wait. So wait, now you will check. It is increasing, 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 increasing. So my flag will say it is increasing. So I will get a I. If I get a I will check that the number I am placing, which is the current digit, which means the current digit must be greater than last digit. Okay. So if I am getting I, my current digit must be greater than last digit. Okay. If this is true, I can return the new flag as same as I. Okay. If this is false, current digit is less than equals to last digit, I can send a new flag which comes out to be broken. Okay, so which is I have broken my like increasing or decreasing format. Clear? If you are getting a D flag, which means you are continuously getting a decreasing, decreasing, decreasing number, so you can again write your current digit must be less than your last digit. Then you can return a D flag. Else, you will return a B flag where your current digit is greater than equals to last digit. Now there is one more case where you can transition from I to D, or not I from D. You have to first assign, like if you are standing on the first digit. Okay, then what will you do? What will you assign here? Like you cannot assign like I, D or B, any of the case. And also sorry, one more thing left before this. uh, Before this, if you get a B flag, you won't even consider whatever you are getting, you will just directly return B. Okay, which means you have a broken index. If the format is broken, uh, furthermore the format will continuously get broken. Okay, clear? Now come to the first digit. If you are placing the first digit, what will you place here? You cannot identify it as I. You cannot identify it as D, or you cannot identify it as B. What I can identify it as? I have to make one more flag, which is start flag, okay? Which means my number is just started. So if it is start flag, I can just say it can be transitioned into I or D, okay, according to the next digit. Like if you have placed 5, okay, then you have placed 6. So the start flag will be converted into I flag. If you have 5, you have placed 1, your start flag can be converted into D flag. Okay. So I have to transition from start flag into I or D flag because I need to know which flag I am currently holding on, because one single digit cannot tell me that which flag I have. It can either be increasing or either be decreasing. Okay. Clear? So I have got three more things. Now I have got flags. I know how to check. Okay. So let's take all these observations down. Yeah. So the next observation which I have, I will make start flag increasing, decreasing, and your whatever what it was like, what was the broken. You will take this, then you just check these flags. Okay, check the flags. How will you check? By considering current digit and last digit. Okay, great. This is clear. If this is clear, you are done. Now, how many of you were able to catch up till here? If this is clear, then your code is done. Like you have nothing more to do. You have just one more thing left, which is continuously take sum at each point. Okay? Make a sum at each point. Then at base case, you can just check if sum is good or not. Okay, sum is good or not. By you can just iterate here. Okay? Just by check by iterating, because n is like length is 18, maximum 19. So you can just check sum is good or not in the base case. Okay. So is everything clear till here? Like if you are able to catch up till here, then your code is done. You don't have to think much. Now we will try to implement this. Okay. Just let me know that it is clear. We will now implement this. Just let me know all the observation, all the points I have made is clear. After implementing the basic idea, we will move towards by digit DP, or by we will not use digit DP, we will just memorize it. Okay, so it is known as digit DP because we are generating all the digits, that's why. But the key idea is very basic and very easy. Okay? Please let me know. Okay, so let's move towards the implementation part. No one is in time. All right, so don't consider this thing currently. Okay? And just hide all of this. Okay. Now look what I've done. Currently what I've done, I have made that I need to find the range. So I will, what I will do, I will find number of fancy from 0 to R and 0 to L minus 1. Then I will subtract them, subtract to get the number of fancy. in between L to R. Okay. So if I do this, I will get a number of n's in between L to R. Great. So my function will be taking an integer as I have discussed here in this diagram. So it will take an integer. It will try to generate all the integers from 0 to that particular integer. Okay. Great, great. Now, if n is 0, then you can just return 0. This is for because your L minus 1 can be 0. Okay. L was starting with 1 and it can be come to 0. That's why. Okay. So now what I've done, I have converted my integer into the string. Then I have called a recursion. In this recursion, what I have index, I have my bound where you can go up to, like what I've told you that if you have bound, you have 5 as your current like reachability, then you can just iterate from 0 to 5. Okay, this is just bound. Then you have a flag which says you are at the start of the index or not, like you are the start of the number of node. Then you have your increasing, decreasing or that particular increasing, decreasing or your like broken index. So I have defined them as increasing will be defined as 1. You can use I. Here I have done 2. You can use D. And here I have done 3. You can use B. It's up to you. Okay. Then I have defined the current between the last element which I have visited. Then I have defined sum, and you have gone a string with the string. Okay. So these are the all the things which I have said. First is index. Second is bound, which means till which I can get to. Third is start. Fourth is what my string currently situation is. Either it is either decreasing, increasing, or broken. The last digit which I have seen, and the sum. Okay. Sum is just for the base case, so I will work on sum at the base case. Okay. Now look, this is my recursion and this is my base case. In base case, your index gets get up to like size of the string. If you are not at the start point, okay, then you just return 0. Okay. Then if your sum is good, you can store that into a boolean form. Else, your your number is either increasing or decreasing. How you check increasing or decreasing? I have checked if it is not broken, it will be either increasing or decreasing. Okay. If the number is not broken, it will be either increasing or decreasing. Okay. Now, if either your sum is good or your number is good, you can just return 1, which means you can form like there is one integer which is fancy, then you return 1 and it will keep adding on from all the branches and go up to root. Okay, as you return 0. Okay, so this is your base case here. Now I have defined a limit till where you can go. It is either bound. If bound exists, which means if bound exists, which means you have to go till particular position, then you have to go like to that position. Like if index is 5, sorry, the element is 5, then you can just go up to 5. Else you go up to 9. And how you are checking that? I just told you how we are checking this with the previous digit. If the previous digit sorry, not previous digit, the current digit we are standing on, if this digit is equals, like if 2 is equals to 2, then you have a tight bound that the next number can be must be up to that particular index 0 to 5. If this digit 1 is not equals to 2, which means you have a loose bound, you can go up to 0 to 9, where we are going from 0 to 9, and it is like logically correct. Okay. So that's what I am doing. If bound is true, which means you have to be strict and go up to the particular element like 5. You have to go from 0 to 5, as you can go up to 9. Okay, now you made an answer as 0, you iterate from 0 to that particular limit, and you assign your new bound. How you are assigning your new bound? It will be your previous bound, and if your I is at limit, okay, then you can go, which means like here, as you can see here, your bound was tight, so bound will be true. But if you go from 20, you can make 201 up to 209. If it was 250, like if it was 250, you can make from 201 to 209. Look, I have gone till 9. Why? Because I was not standing on 5. I was standing on a element which is less than 5. That's why I can iterate from 200 up to 209. All right, so this is clear. Okay. So the bound will only act if previous is strict and currently you are at last digit. Okay, at last digit. Okay? We will try to provide the editorial in the recorded form. Currently, we are not able to do a live discussion. Okay, so the your new bound will be calculated like this. Then your new start. It means if your start was true or your index is like greater than 0, which means your new start will be counted as this. If your start was 0, then you will get a check. If your index is greater than 0, then you can get 1 here. Okay. Now your new uh, decreasing, increasing, or this is like here D is increasing, decreasing slash total. I've written D because I want to classify them as direction. It is going up or down. Okay. So either D is increasing, decreasing, or broken. You just currently put it like D into this. If it is not start, which means you are currently at 0 index. Okay. If it I greater than 0, you can just broke out a new direction as anything null other than increasing, decreasing, or broken, because as you can see I have assigned increasing as 1, decreasing as 2, and broken as 3. So you can assign any random integer like of your choice, 100, 200, 300, whatever you want. Okay, now if it was no, like you are at some particular index, so here it means you are like on the start position, and here it means like you are at some particular index. Now if D was 0, which means you have just completed the first element, which means the first digit has been put down. Now, new digit can be checked by if your current digit is greater than last digit, it will be increasing. If your current digit is less than last digit, it will be decreasing. Or if your current digit will be equal to last digit, it will be a broken value. Okay. So let me just write, if current is greater than last digit, it will be increasing, right? If current is less than last digit, it is decreasing. Here current is equals to last digit, then I can say it is broken. Now if you have D is equals to 1, which means you are increasing. Now if you are increasing and your current digit gets smaller than the last digit, you just transition from increasing to broken. Okay, if your current is decreasing, you are decreasing, right? So if at any particular point your current digit is greater than last digit, you have to broke out. Okay, then you can just add into your answer my recursion next. next index, next bound, next start, next digit, not next digit, no, next direction, your last digit you have seen, and the sum with the string. Okay, then you can just return your answer. Okay, is this clear? So I guess it is just implementation heavy, as the idea was very easy. What you have to do now, and nobody asked me in the comments. I was like surprised. Nobody asked me. Like there was no overlapping sub problems. How I'm using DP here? For example, like it was like 25108. So if this is my indexes, or this is my R is, I can make first digit as 0, 1 or 2, and from 0 I can go up to 00 up to 09. From 1 I can go up to 00 up to, oh sorry, 10 up to 19. For 2 I can go up to 20 up to 25 because it is right bound. Right? 2 and 2 are equal. Then for each of them you can go from 000 up to 009, and you can again go up to like 099 to 090 to 099 and so on. Like the tree will increase. Like then you can go from 0000 to 0009. Yes or no? Where is this? Where are overlapping subproblem? How can you use DP here? It will give TLE. It is just like brute force recursion. At this place, digit DP works because you are not checking any of the previous places if you are standing at this. Fine. If you are currently standing on 9, or let's say you are standing like this, 257, and you are currently standing here, you won't care about 2 and 5. Whatever 2 and 5 had, you won't care. You will only care with the last digit, correct? So last digit was 7, and if I am putting 1 here, I will check. If I was increasing, I have to transition into broken. If I was decreasing, I can transition into decreasing format. I won't check if whatever before 7 was. Okay, if I have put 7 here, then you can transition from either increasing or decreasing to broken. All right. So everything relies on current digit and last digit. Clear? So this won't matter. Yeah, this won't matter. Like if I put 1 here, this particular sub problem can be used in 14471 here. And if there are multiple digits like 0893112, okay, I don't need to calculate them, because if I have calculated till here, I can just return. If I have calculated a value that after 7 1, whatever count is there, like say count was like 63. Okay, so let's say count was like 63. So whatever number comes after this, I will just return 63. I won't transition from 14470089313. I won't transition here, right? I will just return 63 from here, right? This is why digit DP comes in place. Okay, so I'm not going to like write some like very huge thing. What I'm going to do, what are the values which are changed? Index is changed, bound is changed, new start is changed, direction is changed, last value is changed, and sum is changed. Okay, so 1 2 3 4 5 6. I will make a DP of 6 length, or 6D DP, not 6 length, it will be a 6D DP. Okay. So yes, I made a 6D DP which consists of 20, 2 to 4, 10, 200. Why these values? Let's index. Your number is up to 1E18. These are 19 digits. Okay, 19 digits. So that's why I have made index up to 20. Right. Next is your bound. It is a flag, so it can be either 0 or 1. So that's why I have made it of size 2. Next thing, you have a start flag. It is also 0 or 1. So you can just make it of size 2. Next, you have a direction which is increasing, decreasing. So I can write increasing, decreasing, comma broken. So you have three things: 1, comma 2, comma 3. Alright. So that's why I have made a flag of size 4. Then you have a value current digit. Okay. So last digit, sorry, last digit. So the last digit can be up to 0 to 9, right? If it is up to 0 to 9, I can make a size of 10. Now you have a sum. Let's say your number was uh, mm, your number was up to like 9 times 80, 90, or you can say it is a 19 digit number. So all the highest value 9 into 19, it will come out to be somewhat 9 to 18, because like 180 was last one. 9 into 18, it will come out to be some 172, I guess 172 stuff, right? So I can make my size as 200. It will work. Yes or no? If this is clear, then you can, if you look, what is the time complexity of this code? 20 into 2 into 2 into 4 into 10 into 200, somewhat around like 5, 5, 6, something like this. 1, 2, 3, 4. You got three zeros and four zeros. 2, 2, 2, 5, and 2, 6. It was like 64 into 10 to the power 4, which is like 6.4 into 10 is to the power 5. Okay, so 6.4 into 10 is to the power 5. So it will work in like milliseconds. Okay, so sorry. So is this clear or not? Everything what I have told you here, I have just wrote it that at that place. Okay, is this clear or not? If it is clear, then I can just sum up today's contest discussion and we can just meet up tomorrow for weekly. Is this clear or not? Just let me know in the comments. Anything which is like you are not able to grasp why it is here, what work do I have? Tell me, is there anything which is not clear or troubling you in any case? If not, we can just sum up. Alright, no one is replying. I just assume this is clear. Okay, guys, so thank you for joining the post contest discussion. We will meet again in the next live stream. Till then, you can just visit the website and check out the courses. Thank you for joining. I hope you enjoyed the contest and the live stream well. Bye bye. We will meet again.